Section 1.4 Equations of State and the Ideal Gas Law. First, there is no ideal gases in this real world. But why do we study ideal gases? It provides us an easier starting point to look at some gases such as helium, neon, argon, hydrogen, nitrogen, oxygen, because they do behave fairly close to ideal gases. So what's the definition of an ideal gas? First, in an ideal gas, the atoms or molecules do not attract or repel each other. 2. The size of the individual atoms or molecules in the ideal gas is 0. Can you imagine the radius of a gas atom is exactly 0? Well, it does not exist in this real world. However, if the size of the atoms together is much smaller than the volume of the container of the gas, let's say this number 2 is roughly true, approximately true. Alright? So again, if the atoms and molecules occupy only 0.001% of the container and 99.999% of the volume of the container is void, and then maybe we can say this is roughly true. Number 3, all collisions are elastic collisions. What does elastic collision mean? It means the total kinetic energy of all colliding parties is conserved. For ideal gas, we can use the famous PV equals nRT to relate 3 very important thermodynamic properties: pressure, volume, and temperature. For a mixture of 2 ideal gases, if we know the number of moles of these 2 gases, we can compute the partial pressure of these 2 gases by using P sub A equals N sub A times RT over V. T is the temperature of the gas mixture, V is the volume of the container. And what's P total? That's the sum of the partial pressure of A and the partial pressure of B. It's equal to N total times RT over V. N total is the sum of the number of moles of A and B. The partial pressure of a gas in a mixture is proportional to the mole fraction. So this X is a mole fraction, and PA over P total is equal to the mole fraction of A. The derivation is over here. Again, we used the ideal gas law for gas A. We also used the ideal gas law for the mixture. And then you can see PA over P total is simply NA over N total. That's the mole fraction of A. Similarly, pressure of B is the mole fraction of B times the total pressure. What if we have more than 2 ideal gases? We'll resort to this sum sign. The total pressure is the sum of the partial pressures of all species, and then P sub I is the partial pressure of species I. It's equal to the mole fraction of this species I times the total pressure.